Hello, good morning. This video is to address some of the problems I see you guys have when you're doing your line plots and fractions. And I can see from the result of some of your homeworks and some of the work you do in class that we get confused with doing line plots and fractions, especially when the denominators of the fractions are different. But I'm just going to give you a brief outline on fractions before we go into the type of problems I'm talking about. The problem I have here is Sarah measured the amount of daily snowfall in December. She recorded the following amount in inches: 1/4, 3/4, one quarter, 3/4, 2 1/4, and a quarter. Now, a lot of you don't have problems doing line plots that have this kind of data because the fractions have the same denominators and you know to divide the whole into four parts. Now, the problem comes when you have to do fractions that have different denominators. They are not really different, but I guess the fractions are reduced, so that kind of throws a lot of you off, and you think is a trick question. But remember what I always tell you, and remember my great rap song: thinking and tricking, thinking and tricking, thinking and tricking. All right, I won't go into all that now. So when I come to class, we'll go over it. Just to let you know, I'm having some producers approach me so that we can do a recording of that great song. Anyway, back to our math problems. Now, problem number two we have I'll read it and then we'll see the data that was collected. Now it says Kevin interviewed some local dessert chef. He asked them how many cups of chocolate they use in a batch of chocolate candy bars. The number of cups used per chef is as follows: 1 3/4, 1 3/4, 178, one half, 1 3/4, 1 3/4, 158. Now that is the data that Kevin got, and they are all in cups. Now, most of you or a few of you get confused when you see that the fractions have different denominators. All you have to do is think. Nobody is going to trick you in a math question. There are no tricks. They just want you to think a little bit. Remember, thinking and tricking. So what you have to do is change the fractions denominators to make sure they are the same if you cannot understand it this way. Some of you can do it the way it is, some of you cannot, but we'll just try to break it down. So what you have to do is, like we've done here, we're going to do it with 1 3/4. So if we multiply the denominator and the numerator by 2, we should get 168. And we will do that also with 1 1/2. With that, we'll multiply the numerator and denominator by 4. So it will be 1/4. And then we don't have to do anything to 158. So we'll leave 1 3/4 alone. We've done that already. It becomes 168. So from our data set, we have is the same data, but just few of the numbers have different denominators. But when you reduce the fractions, you will see that they goes back to what it was before. So the data we will use are the following: 168, 168, 178, 148, 168, 168, 158. Now, for the sake of time, I have done the line plot, so we don't have to worry about that. So if we can bring the line plot up, I'll try to bring it up. We'll see that it's been done. Okay, there it is. The line plot has been done. My writing here is a bit off. The writing is a bit off. I'm just going to get rid of this pencil pen. So the writing is a bit off. Now we see we have 168 cups 4 chefs used 168 cups to make their batch. 1, 2, 3, 4. And 1 chef used 158. 1 chef used 148. And then 1 chef used 8. Now, this 148 is the same thing as 1/2. So 4 divided by 8 is 1/2. And then 168 is the same thing as what? 3/4, right? So you divide that by 2, you got 3/4. All right. So this solves the problem, and you have to make sure you keep practicing. And I'll see you in class next time. Thank you.